Hello, Math 140 students. We will be picking up on page 9, section 5.3, adding and subtracting polynomials. So here in the first example, we want to go ahead and add and subtract as indicated. So we see that these two polynomials, so let's call the first one the green polynomial and the second one the blue polynomial, and they're being added together. Since they're being added together, then we can just realign them so that it corresponds to the matching exponent. So I have a 1m to the 3. I have a positive 2m cubed. I have a negative 9m squared and a positive 3m squared. And I also have a positive 5m that doesn't combine with anybody, and a negative 4, and I can't forget my negative 1. So I can see that m3, negative 9m squared, the 5m, and the negative 4 are all accounted for in the green polynomial. And in my blue polynomial, I have that 2m cubed plus a 3m squared and the minus 1. So now I'm just going to be adding these together. So I have my 3m cubed. I have a negative 9 plus 3, which is a negative 6m squared. I have that positive 5m and a negative 4 and a negative 5, which is a negative 4 and negative 1, which gives me a negative 5. And so that ends up becoming my final answer. Now you have to be a bit more careful when it's a subtraction, because when it's a subtraction, you can think of it as a negative 1 that's going to be distributed to everything. So you really have a y squared plus 3y plus 6, but now since you're distributing that negative, it's going to be a positive 5y squared, a negative 3y, and a positive 8. So now I want to combine my y squares. So I have 1y squared plus 5y squared, so that's a 6y squared. Next, I have a positive 3y and a negative 3y. Well, those cancel out. And the last thing I'm left with is a positive 6 and a positive 8. So 6 plus 8 is going to give me a positive 14. So that's going to be my final answer. Now for this one, you just have to be careful about this negative here. So I'm going to have to distribute it into everything here, okay? So I really have an r3s squared plus 2r squared s squared plus 10. I also now have this negative 7r3s squared. And since I'm distributing a negative, it would be a negative 18r squared s squared and a positive 9. And I have the last thing, which is that 11r3s squared minus 3r squared s squared minus 4. So now you just want to be careful with what you're doing. So it looks like I have an r3s squared. So I'm going to look for things that are similar. So r3s squared. This is also an r3s squared. And I also have this r3s squared. So I'm going to combine those together. So you can think of this as a 1. So 1r3s squared minus 7r3s squared plus 11r3s squared is a positive 5r3s squared. Now let's look at all the squares. I have an r squared s squared. So this is also an r squared s squared. And this is also an r squared s squared. So now I'm going to be adding all of my green values together. So I have a 2r squared s squared minus an 18r squared s squared minus a 3r squared s squared. So that's going to give me a negative 19r squared s squared. Now I have a positive 10, a positive 9, and a negative 4 I'm going to be combining together. So it's 10 plus 9 minus 4, and that gives me a positive 15. And so that is how I added and subtracted for number 3. And so section 5.3 continues. We have our product rule. So if we have our product rule, that means if I have x to, like, let's say m times x to the n, then it'd be x to the m plus n. For example, x3 times x squared is going to give you x to the 5th power because you're adding that 3 plus 2. Now for my power rule, if I have x to the m to the n power, that would be x to the m times n, so I would be multiplying. So for example, x3 squared would give you an x to the 6th power. And anything to the 0 power is always going to give you 1. So let's say I have 5x squared y3 all to the 0 power. That's going to give me equal to 1. And now remember, if I have a negative exponent, so let's say I have 4x to the, let's say, negative m, then that's going to give me a 4x to the positive m. So just remember that that negative exponent here tells you to rewrite it in the opposite side. So if I were to have 4x to the negative 3, well, since it's negative in the denominator, I'm going to bring it to the top as a 4x to the 3rd power. And my quotient rule, if let's say if I have x to the m over x to the n, it would be x to the m minus n, so you're going to be subtraction. So for example, if I had x to the 5th over x to the 3rd, then it would be x to the 5 minus 3. Well, 5 minus 3 is 2. So let's think about some of these examples. So here I can see that they have the same base, so it'd be 3. So what ends up happening is we end up adding these exponents together, so 2 plus 5. So I'm going to end up with 3 to the 7th power as my final answer. For number 2 here, it's multiplication. So multiplication, it doesn't matter in what order you multiply. So I'm going to switch this around as a 9 times 3, y to the 5th, and y to the 8th. So now I have 9 times 3, which is a 27. And I also have my 5 plus 8, since I'm adding the exponents together. So 5 plus 8 is going to give me a positive 13. So 27y to the 13th power. Likewise, for number 3, I'm going to rearrange this a bit. So I have a negative 5, 6 times a 2/3. Now I have an a squared and a to the 5th power. I have a b times a b to the 4. And I also have a c3, and that's it. So I have my 2 a's, I have my 2 b's, and I have my 1 c. So now I'm just going to multiply. It might be easiest to just think of 2 divided by 2 is 1, and 6 divided by 2 is 3. So when I multiply, I'm going to get a negative 5 over 9. And I have a to the 7th power since I'm adding them. That's really a b to the 1 power, so that's b to the 5th power. And I still have my c to the 3rd power. So remember, you're adding the exponents together. Now what's different with number 4 is that the exponent's on the outside of the parentheses. So that means I'm going to have to distribute to everything on the inside. So now I have 5 to the exponent of 3 times a to the 6, and it's going to be multiplied by that 3. So now I have 5 to the 3rd power, which is 125, and 6 times 3 is going to give me a positive 18. So now I have 125 a to the 18th power. For number 5, what I want to do, again, is I want to distribute this 3 to every single thing. And I have 3 things in there. So I have my negative 5 over 3 to the 3rd power. I have my t squared. That's going to get multiplied by 3 as well. And I have my u to the 6th power also being multiplied by 3. So now I have the fraction of a -5 over 3 that's going to get multiplied together 3 times. So -5, -5, -5 being multiplied is a -125. 3 times 3 times 3 is 27. I have t to the 6th power, and I have u, and 6 times 3 is going to give me an 18. Now I'm just going to make that 5 look a little bit better. So 125. So that ends up becoming my final answer. For number 6, it's the same process where I'm going to kind of just separate the numbers here. So I definitely have that -5. Here, don't forget that's really a -1 here, if you want to think about it that way. And I also have my times 4. Now I have my m to the 3, and m3. So I have m times m3 times m3. And I also have my n power. So I have an n to the 4, an n to the 9, and an n to the 1 power. So if I multiply my coefficients together, I have a -5 times a -1 times a 4, which is going to give me a positive 20. If I'm counting all the exponents on the m, and remember that first m doesn't have 1, so you put a 1 as a default, so 1 plus 3 plus 3 is going to give me an m to the 7th power. And now, when I think about my n's, what would be 4 plus 9 plus 1, since I'm adding all these exponents together. So 9 plus 1 is 10, plus 4 is going to give me a 14. So I have 20, m7, n14. And that is the end of this section. Thank you.